Hi, and welcome back to API Can Codes Unit 2, Computational Foundations of Data Science. In Lesson 2.2, Manual Data Processing, students will do some basic data manipulation from a CSV, first in Google Sheets, then briefly in EduBox. The goal of this lesson is to primarily suggest the benefit of programmatic manipulation of data over manual manipulation. We recap 2.1, including the food deserts data investigation, and the video on when TikTok songs go viral and how data science gets used to examine that. We also mention that graphic at the end, looking at data science as the intersection of several different fields. Students can open the Open Data DC Streetlights dataset in Google Sheets. This dataset has a bunch of different information, location and what it's made out of and what the pole it's connected to is made out of, information about every streetlight in DC. We want students to spend a few minutes exploring the dataset. Please note that in this slideshow, slide 2 is hidden and it walks through students through the process of downloading the CSV from Open Data DC. If you'd prefer to do it that way instead of using the Google Sheet, that is an option. The next few slides will walk students through some manual manipulation techniques in the data. The first is looking at missing data. Control and A will select the entire dataset, and then you can go to Format and Conditional Formatting. What we want students to do is format the cells using the isEmpty criteria and color the cell any color you want. And this should make it easy to scroll through the entire dataset and see if there are any missing values where there's just a blank there. That might be some missing data. And students might think about at the end of the slide if there are any other cell values that they'd want to have highlighted. This and the next slide look at the COUNTIF function, which looks at a cell and produces a certain value if that cell's content match a specified number or a string of text. On this slide, we show students how the COUNTIF function is broken out, including the function name, the range of values that it's searching through, and the criterion that it's using to check for a match. Next, we apply this function to the fixture style description, which in the Google Sheet should be column O. We're going to have students scroll to the bottom of this column and enter COUNTIF 02 to 072037, posttop. Posttop being a fixture style that is in that row. I mention this only because students might be downloading a new version of the sheet and using that instead. There's a possibility that that 72,037 number might need to be replaced by whatever the last row of data is in your sheet. Since that downloaded data may differ slightly from our version if DC adds some new streetlights. We want students to press enter, see what that number is and what it means. We're going to do a similar thing over in light manufacturer description. In this case, we'll look at column Y for any streetlights that have General Electric as the manufacturer. We also want students to think about how missing data cells might affect these counts. And because they've already highlighted the missing data cells, they should be able to quickly scroll through the data set and see how many are missing. Our next look is at using functions to calculate statistics. So students are going to use the average function to calculate the average wattage and then pole height in these two different categories. There is a problem with the second function that we want students to explore. The problem is that this column is actually storing a string. Each cell contains both a number and the units, which in this case is feet. So to calculate the average of these values, we'd need numerical values only because this average function will not take that feet part very well. Next up, we're going to look at some transformation. In column AG, we see pole composition description. We're going to create a new column, and the way this column is going to be filled is if the AG value is wood, then this column will store a yes. If it's not that, then it'll store a no. So we walked students through the process of doing this here. This is something that much down the road in this course will pop up because we want students to be able to create sort of binary variables to store yes, no, if another variable meets a certain value. So that's kind of what we're preparing them for here. And now we'll make our switch over to programming. So we're going to use a program called EduBox through this course. This lesson is the first time students will see this. EduBlocks is allowing students to create code in Python, but it is block-based. So it won't look exactly like text-based Python if you're familiar with that, but it should look similar. We want students to start thinking about benefits that this programming might offer over the manual work we've already done. So again, here's an introduction to EduBlocks. On the left side, you see the block-based view. On the right side, you see the code view. And the code is actually exactly the same code that's represented in blocks on the left. So as students put together their program in blocks, it will get recreated in text over on the right. We're going to have students use a pre-made program today. It's linked in this slide. Students are going to run this program and it should print out one chunk of the data. What students might notice, a couple things that we want to highlight, are that first of all, the data structure is quite different. It's no longer tabular and it's organized in a different method. So they should think about what that looks like. Next, we're going to have them connect a lower chunk of code. This starts with would count equals 0 if students are looking for it in the program. And we're going to connect that to the top, and then we'll rerun it. So each block in the code represents a line of Python code. You can see the text equivalent on the right side. Students might recognize some of these parts. They might not recognize other of these parts. Really depends how much programming background they have. We want to highlight this green if block. So this is the block that has if lights properties poll composition desk equals would. We want them to think about what criteria is required for a match. For a match here, we would need the within lights, within properties, and within poll composition description that would need to match the text would. If that if statement criteria is met, then we will add one to would count. If it's not, then we won't do that. What we should see is at the end of this, our would poll count that prints out should match the output of our count if statement on would polls from earlier. So this is a programmatic way of doing that same count if statement that we did back a few steps ago. We want students to think about the difference between this block-based programming process and our Google Sheets work. Part of the challenge to doing this in Google Sheets is that you have to scroll through the data set for things. You have to put functions and things on the last line or somewhere that's not sort of easily accessible. On the other hand, students may find the programming a little unfamiliar, especially depending on their programming background, and that may be its own kind of challenge. Students often, if they're new to EduBlocks, they often describe it as more complicated with the Google Sheets, but they also tend to describe the Google Sheets as slightly more challenging or tedious manual work. Today's exit ticket has students thinking about the application of the functions that they used in today's class, and also, again, how missing data could affect the output of those functions. As always, thanks for watching this lesson walkthrough, and thanks for teaching the API CAN code curriculum.